This conference will now be recorded.
Okay, now before we proceed with next topics, let me just show you how do we create a cluster. Okay, now if you remember, I was telling you that if you want to create a cluster, there are different ways to do. Okay, so one of the method what we are going to now is to do a raw installation. When I say raw installation, you are going to have some machines, which could be a physical machine or a VM, or it could be just a machine from AWS or Azure. And on top of that, you will install Kubernetes using kubeadm. Okay, so that's a command. However, instead of we doing all those things separately, there are many services available in AWS or Azure using which directly we can create a cluster. Like in AWS, we have EKS. Okay, now for your practice purpose, I don't want to go into that because of two reasons. One is if you have to create a cluster using EKS, there are a lot of administration tasks that you should know in AWS itself. Okay, that is one. And the second one is they charge heavily for it. So for your practice, if you have to keep it for a longer time, it'll be too expensive, and you need to know a lot of things on your AWS administration. So that's where I'm just going to show you on how do we set up a raw installation on taking couple of machines in AWS. Okay, so that way we will take some machines and we will just set it up as master and slave so that it will be easy for you to practice all of them, whatever we are going through. So from that perspective, let us first set up master. Okay, so for master, what we have to do now is, again, I need to take up a machine. Now, the master machine, whatever that we need, should have minimum of 2 CPUs. Okay, so that's what I did when we took the Minikube. So that way, for master, what I'm going to do now is create a machine with minimum of 2 CPU. Okay, so let's say launch. It's kind of slow. Okay, I'll take Ubuntu 18. And this is where I'll take T2 medium so that I have minimum of 2 CPU. Yeah, this will be chargeable. That's because we are not using T2 micro, but it will not be that much comparatively what we are going to use EKS, right? So that's the reason we're just doing everything from the raw installation. So take one machine. So I'll use our existing security group, which is the default. And I'll put it up to a key, and then let's go ahead with the machine.
Adam, how much free as will have for T2 medium?
Sorry?
How much free as we can use for T2 medium? You said it
There
will
is
be
no free
charged.
hours in T2 medium. T2 medium is chargeable right from the first minute. Only T2 micro is free.
Okay.
Okay. So any machine other than T2 micro is chargeable. So we have one machine that we will set it up, but however, we also need machines to act as worker. So again, what I'm going to do, let me go ahead and just quickly create a machine, which we will use it a little later. So now I'm going to take again two machines which will be acting as slaves or nodes. So for that, once again, let me take Ubuntu 18. Okay. But for my worker nodes, it's all about how much of capacity that you need based on your containers are going to run. So ideally in a real time, whatever we are doing will not be the method, because if I need, let's say, 10 containers and each containers is 4 GB, my total cluster capacity should be minimum of 50 to 60 GB, right? So that way each machine, how much you are going to take, that's a different calculation. But for practice, we really don't need anything so huge. So just keep the master as T2 medium, but now go with the slave machines as T2 micro and just make it as two machines. And I'll use the same default security group and launch. Okay. So now we just created whatever the machines that we need. So there is one master and two workers. So earlier the worker nodes were called minions. Now they don't call it as minions, it's just node, but it's kind of a catchy name. Let me just put that. Let's say Kubernetes minion 1 and Kubernetes minion 2. Now let's set up the master. So I'll connect to the master. Okay, so now whatever the components that you're going to install, whether it's master or your minion or worker, the base for that is you need to have Docker. So first, let's go ahead and install Docker. Okay. So I'll say apt update and apt install Docker. And once this is done, okay, so now the next thing, suppose if it's installed, what we have to do is we have to install some components of your master in which we will be having kubeadm. Okay, this is what is most important. Now for this, we need to tell from where the packages has to be downloaded, because when you say apt, it needs to know a repository from which it has to download. So if you go back for Jenkins also, we did the same, where we told from which repository it has to download Jenkins. The same way, we are now trying to tell what is the location of the repository from which the apt packaging manager should be downloading these components of Kubernetes. So that first we will add the key for the repo. And then I'll add the location. Okay, and once done, just do a apt update so that whatever the latest repo that you have given, it will try to sync up to that. Okay. Now, once it is done, I need ideally these components. Okay. So come here and do a install of these three. Okay, just to cross check, if you just say cube ADM, you should get it, and which kubectl you'll have, and you can say cube ADM version. So we are using 1.18, and which cube CTL. Okay, that's cube CTL version. It's 1.18. Okay, so this is your version of the Kubernetes. So if someone asks you what version that you're using, you can just go ahead and say the latest version, which is 1.18. Now, we just have installed the primary components, okay? But we need to set up the cluster. So for that, the next step, what we have to do is this, which is important. So once you have installed these components, the next thing what we have to do is actually create a cluster. See, it's like your WhatsApp. The first thing that you will do is create a group, right? Now, in that way, when you're trying to create a WhatsApp group, it will ask you to add some person to it by default. So that way, in Kubernetes, when you run this command called kubeadm init, you are trying to create a cluster starting from the machine on which you are running it. So whatever the machine you run becomes the master. Okay. So I'm trying to say that create a cluster. Okay. So now internally, this will start all the services which is needed for Kubernetes. Okay. Okay. Now there are a few words that you have to keep noting it down. So there is something called as C group. Okay. Now, if you take Docker, right, the native Docker, so that also has namespaces. Okay, but traditionally those are the namespaces which is being given more from the OS, because the OS also has, I mean, an operating system also has the concept called namespace, and they also have things called as C group. Okay, so this namespace and C group is what Kubernetes is using to provide the actual namespace. So that way, whatever the namespace that you saw from Kubernetes, the functionality is actually being obtained by the operating system namespace. Okay, so that way, if someone suddenly asks you what is a namespace in Docker, it's nothing but whatever the definition we have for Kubernetes, tell the same. And if someone asks you the next question, okay, what is C groups in Docker? Then if you come back in a namespace, or the question is, what is a namespace? So namespace is a collection or a group of objects. But in that, for a namespace, you can specify how much of resource that you can use, which is the quota or the limit range, right? So that functionality is given by the C group. Okay, so that way, with the help of the OS namespace and a C group, in Kubernetes, we can define or create something called as namespace and give what is the resource quota. Okay, so it's just a generic question. If someone asks, right, don't just be thinking like, hey, what is this? You just have to immediately say, yes, this is what it is. Resource quota and the ability to say how much capacity to use is what we call it as C group, or that is the functionality of the operating system which is being used by the Kubernetes. Okay. Now, when you ran this, it actually gives you an output which calls as kubeadm join. Now, again, this is like your WhatsApp. After you create a group, if anyone else wants to join your group, you just have to give them a link using which they'll be able to join, which is like a token for your group. The same way, now on any other machine which wants to join as a minion or a worker to the master in a particular cluster, then we are going to use this. Okay, so that's when now what we need to make sure is copy this so that on any other machine which is going to act as worker, from that machine you are going to just run this. Okay, so that is what is most important. So let me just make a note of it separately. Okay, so this is a token to join the cluster from the worker node. However, now once you have done with this, the next step what we have to do is we need to make sure that the port number, whatever that we got here, that is 6443, is being added to our inbound rule. Because now understand, you have to run this command from the worker node so that the worker node will be communicating to the master using this port number and add to the cluster on the token what we have given. So that's where we need to make sure immediately that in the security group on the inbound rule 6443 is enabled. So quickly let me go here, come to security group. Okay, this is the default group we have used. Edit inbound rule. Here, just go ahead and add 6443 in case if it's not there. Okay, I'm just going to save this. Okay, it says it's already available. Okay, that should be good, no problem. So now we have done that step also. Now, once you have the token generated and you have ensured that you have added the 6443 what we got from the token. Now the next thing is going forward on the Kubernetes master, if you want to run the kubectl, you should not be running it as a root, because in Minikube we were always running it as root. So now specifically we need to run it as a user. So that is where whenever you are running kubectl or kubectl, what actually happens is it reads a file called a config file, which will be available in the home directory and .kube folder. So assume that if you are running it as user called Ubuntu. So what happens? The kubectl will need a configuration file called config file, or this is what we call it as kube config file. By default, it will be searching in the home directory .kube config folder. So if I want to run the Kubernetes master or the Kubernetes kubectl from the master, then I need to make sure that I have the copy of this file. So by default, when you install everything as root, the file will be available under etc kubernetes admin.conf. You copy this as a kubeconfig file under your home directory or as the user as whom you want to run. And then from that user, if you try to run the kubectl, it will be accessible. Okay, so remember, the kubeconfig file is an important file, which is what is going to allow us to communicate to the API server. Okay, so I'll talk about this in details what you have, but right now remember, when you invoke kubectl, kubectl will be reading this configuration files to execute or to communicate to the API server. Okay, so that's where what we will now do is we will try to create a user, or we already have a user called Ubuntu. So all I'm going to do is, if I just say, okay, it just came back. Anyway, if I go back to the machine again, now I'll be connected as Ubuntu, right? So I want to now copy this. So first I'll create a folder called .cube, and then I'll copy this file. Okay, so the config file, and then I'll give permissions for the user, because I'm running as Ubuntu. So now if you see, there would have been a folder called .cube here in my home directory, and there is a file which is readable by Ubuntu. Just to show you, if you edit the file, you can see there are some information on where it has to communicate. Okay, now it knows where is the server available, because internally it is going to refer to this location only for communicating to the API, because whenever you call kubectl, the kubectl will be communicating to the APIs which are available in the server, and this is the location of your master. Okay, now, and then there is few more things which I'll talk about a little later, but for now, try to see that you are now running as a user called admin. What is this user? I'll just touch base later. But remember now, when you are running your kubectl, it is communicating to this master, which is nothing but the same machine, as well as it is running everything as a user called Kubernetes admin. That is where whatever that in fact we are going to do, or you are doing it in Minikube, you have permissions for everything. But we can also restrict the permissions on what you should be able to do, what you should not be able to do. Okay, so those kind of things is what we call it as role or service account. But for now, just remember that we are copying this file, and because of this file we are able to call the kubectl and communicate to the master, and from the master the API objects will be reachable for us. Okay, so now all you did was initiated a cluster, you got a token, and then you went to your user and copied this file. Okay, then once this is done, so the next activity what we have to do is create a network. Okay, because your pod should be able to communicate, right? And your master should also be able to communicate. So that's where we need to create a network specifically for your Kubernetes. So for this, there are many types of network. One of the common one that everyone uses for raw method is called as flannel method. Okay, so I am just using this YAML and applying, so that now it will create a pod, and that pod will be having all the details that you want. So that is how everything is going to be pod in Kubernetes. So it's not just we are creating, whatever Kubernetes manages, it's also pods for its internal reference. Okay, so see what happens when I run. So once you run this, you would see that there are a lot of things that it is doing, like policy, and then role binding, service account, and everything is being defined. Okay, now to cross check, go ahead and say kubectl get all, and you should see this. And now here you can say namespaces. Okay, let's not worry. To go back, let me show you the command. Okay, all namespaces. So now if you want to get all the pods from all the namespaces available, right, then we have a command called kubectl get pods -all namespace. Okay, so then what will this do is, now if I enter this, you can see other than our default namespace, there is another namespace called kube system, which is mainly used by the Kubernetes administration. Okay, now inside that, it has created couple of components. Okay, now in that, have a look. There is something called as etcd, and then controller, okay, and then scheduler, okay, and you also have proxy. Now these are the components of your master, which is going to take up everything. Okay, so again I'll touch base this. So now we have installed our master. Okay, now when you have installed your master, in master there are couple of components that we have, okay, which we need to know. So probably now I'll just tell you the components of master itself. So when you take a master, okay, now in a master there are 4 major components available. Okay, one is called as the API server, and then scheduler, controller, and key store, or what we call it as etcd. Okay, now these are the 4 components that we need. Now ideally, whatever that we are communicating, right, will be through API server. So when you execute your kubectl, your kubectl or kubectl will be actually communicating to the APIs which are available in your Kubernetes. Okay, so for that we are using that config file, and we are telling where is the APIs which will be available or accessible through the port 6443. Okay, so that way all the user communication happens only to this API. Okay, so remember, these APIs are provided by a component called API server. Okay, now whatever information that you are going to give through a YAML file or a manifest file, then what will the API server will do? It will try to receive, because now assume when I say kubectl apply, okay, what will happen immediately is after we say kubectl apply, the API server will take all the information that whatever that we have given in our YAML file, and that it will try to pass it next to a component called key store or etcd. Okay, so what will that etcd do now? You can, it's not a database, but assume of think like it is the actual brain where everything is getting stored, so that whatever the information we are passing, the API server or the APIs will read, and it will store into this place called etcd. Now this is called as the key store because whatever the information that we are giving will be stored in the format of a key and a value. That is why we are using a YAML file, right, which gives us a key and a value. Now once the etcd stores all the information, then there is a next component called as controller. Okay, so what will this controller do is the controller will be actually doing something called as service discovery. That means controller will be communicating to all the machines, and it will be collecting the information whatever the Kubernetes needs. Okay, so in that way, when the controller kind of reads all the information, then it will try to compare what is the information that it has got, which is what we call it as the status, and what is the objects that is available on your key store, and if there is a mismatch or the state whatever you have defined is not matching with what Kubernetes has obtained through the controller, then the step what we have to do is it needs to schedule what it has to do. Because for example, now you have told kubectl apply and you need 2 replicas. So in the key store there will be definitions about your object which says 2 replica, and when controller fetches the details, if it is only 1 replica, then it needs to now increase it to 2 replica. Or if this is the first time that you are seeing kubectl apply, then the controller will now need to decide to create 2 replicas. So that is what the controller is going to do. And controller is the one which decides now where should be the pod get assigned, and in that to create container. So those kind of information controller will manage. Now if you go back in the node label I showed you, right? When you apply, I told you that Kubernetes will check for the machine which has the resource needed for you, and in that machine it will be assigning the pod. So that duty is actually done by controller. Okay, so this is the one which will be checking the data from what it has received from the minions or the nodes and against the data what it has in the etcd. And for that it will be taking the help of scheduler, and it will be telling that, hey, exactly at this time go to this place and do it. Okay, now even when we went through the health check, it has to do something very periodically, right? So those kind of activity, it will be taking the help of scheduler, and scheduler will be actually running the tasks. So that way, now you need to remember that whatever we communicate, it goes to APIs, and the APIs will collect the information and store it to the etcd, and the etcd component will be trying to maintain the status in which the controller will try to maintain. So this is what we call it as like a pilot, so which takes care of everything. So this collects the information from the worker nodes and checks on the etcd, and based on that what changes it has to do, and it is going to take the responsibility of maintaining. And in that it is going to take the help of the scheduler to dispatch what exactly it has to do. Okay, so which node it has to go. So those information controller will give to scheduler, and scheduler will be dispatching the actual work. Okay, so this is where we have this 4 components, and that's what we saw here. Okay, so you have your etcd, your API server, your controller, and scheduler. Getting it? The 4 components of master. So remember, we communicate only to API server. API will communicate to the etcd, and then the controller will be driving everything which reads the information from etcd, and as per what it has to do, it will go to the scheduler and it will try to dispatch the workload means, yeah, this machine you have to go, this container you have to monitor or health check. So those kind of things it will do. Okay, so these are the master components. So now we have our master components available, and now going forward anytime I should be running the kubectl as Ubuntu user. So here if you say kubectl get pods, there should be nothing available, and you can also say kubectl get nodes. So there's only one machine which is acting as master, that's our current machine. So now let's quickly create the 2 workers that we have. Okay, so now for that let me create a command prompt. I'll just need 2 command prompts. Okay, so let me go back. Now let's connect to the first worker. Okay, I'll go as root. Okay, same way, let's go to the other machine also. So I'm just going to the third, which is nothing but our second node. Okay, So now, what is that we have to do on the worker? Okay, now first let's see the components of your worker. I mean the steps that we need to install, right? And then we'll just come back and I'll talk about the components. So now, in order for us to set up the worker, once again, I need to install Docker in it, and I don't need to install all the components. The only component that you're going to install on your worker is the kubeadm. Okay, so now let's try to set this. So now on both the machines, I need to first install Docker, and then we need to set up the registry so that it knows from where it will download the kubeadm. And once it is done, whatever the tokens that we had generated earlier, right, using the kubeadm init, that you're just going to run. That's it. So now quickly on both of these machines, I'll just say apt update and install Docker. So while it is running, I'm just going to do the same on another machine, apt update and install. Okay, so this will install Docker on both the machines. Now, the next step, I need to add the key. Okay. Okay. So let me just go ahead and add the key. Okay, same way I'll add the key for the second node. So I'm just trying to do both in parallel. Okay. Now once you have added, the next thing is add the repo. Okay. And run the same thing on second node. Okay, so once it is done, now all I have to do is install the kubeadm component. Okay, but before that, just do a apt update. So let me go to the first worker. Okay, let me clear the screen. So I'll say apt update and apt install kubeadm. Same thing over here. I'll go to the second node. Okay, in this again, I'll say apt update, apt install. Okay, so now we have the worker or the node setup ready. Okay, but we haven't joined to the Kubernetes master cluster yet. Okay, so for that, now on the worker, you need to run this command. Okay, so this is where we just need the kubeadm, nothing else is needed. So now on both the machines, you have to run. So let me just show you one by one first. So I'll go to first worker. Now in this, run this command. So internally, you should see that it's trying to start something called as kubelet. Okay, now here we have the machine connected to the master. Okay, so now let's go back to the master. So from here, if I say kubectl get nodes, okay, so here you should be able to see that there is one machine added, correct? Now this is what we call it as worker. Okay, so this is the machine that we added. Same way, let's go to the second worker. I'll clear the screen. Okay, and here I'll run the same join command. So now it should get added. So that's where now both the worker machines have been added to your cluster. Okay, so if I come back to my master and if I run kubectl get nodes, you should see the other one is getting ready, but there are two machines available now. Okay, so this is where you have your cluster ready, where you have one master and you have two worker machines. Okay, so now what are the components that you have in your worker using which you did a join? So for this, if you go back to your components, right? So now let me just explain you the worker. Okay, so what we saw was the component of master, which is API server and etcd, and then we had controller and scheduler. Those are the four components. Now, what do we have in the worker? So in the worker or minion, if you see that when I actually did a kubectl join, it started some service called kubelet. Okay, now this is the component which will be actually communicating to the master. Okay, because anything that request is coming from the master, correct? Now that will be received only by the kubelet. Okay, so what is kubelet service is going to do in the node? So kubelet is the one which will be giving all the information about the machine in which you are running it to the master. Okay, and in that it is not going to just give, but it is also going to receive the workload whatever the master scheduler is trying to give. So that way all the information about your worker on what is the container running, and in that container what is running, and then the status, what volumes you have, what capacity we have, everything will be given back to the master using the kubelet service, which is what we just now started. Okay, so now if you go back and understand, the master will be communicating to the kubelet, and kubelet will be communicating to the Docker daemon and create the container. Okay, so this is the first component that we have in your node. Along with this, there is one more component called as proxy, okay, which is again a small service which will be running inside your node. So what is the need of the proxy? Now proxy is nothing but what we call it as kubeproxy. So if you go back, we understood the service, right? So when I define a service, there were a VIP which is available, and that VIP was helping us to kind of communicate or load balance to the pods. So how did that happen? That happened using kubeproxy. Okay, so kubeproxy will be helping us to read the information. Like if I have a VIP, in that VIP, if I have two replicas, I don't have to worry about where is my pod running, correct? So that's sort of things is what is done using kubeproxy's help, or kubeproxies will be helping us to manage the ports which is being taken by the service. So these are the two components that we need to know. Okay, now ideally going forward, if you have a cluster, so you will call the kubectl and you will be passing your manifest, which will be reading by Okay, let me just put everything together now. So we will be passing the manifest file, okay, through the kubectl, and in the kubectl we have defined a config file which is called as kubeconfig, which knows where is your Kubernetes master and where is the API server available. So that was the port 6443. So that way we will pass the information on the manifest file to the API server, wherein the API server has different APIs which will collect the information and it will be storing it into the what etcd of the master. Then there is a controller component which will be reading the information from the cluster as well as from the etc, and then it will try to see if there is any change that it has to do. So based on that, it uses another component called controller and scheduler, and with the help of scheduler it will try to say, okay, this is what you have to do, wherein the master will be communicating to each node, wherein in the node there will be a component called as kubelet, which is what will be collecting the information of each machine and will be giving back to the master. And in the node, the kubelet is what will be communicating to the Docker daemon to create a container and manage things. So kubelet is the important thing in the node which does the activity. And in addition with the kubelet, we also have another component called kubeproxy, which will be running on the node. And this is the one which will be helping us to define the service VIP and able to communicate to the port in the cluster. Because we saw that, right? I can go to any machine, and if I use the VIP or the IP of the pod, I'll be able to access it within the service. So that has been helped through kubeproxy component. Okay. So again, it might be an entry question many people would be asking. So be clear. Okay. So clear so far on what is the cluster setup and what are the components of master and your worker.
Yes, sir.
Okay, so going forward now, we will not be communicating directly to the worker, because anything that we have to do from the master, okay, or from the machine where you have your kubectl available, which will be communicating to the API server. Okay, so that's where our communication should be only with the master, not to the worker. So that is the job of the Kubernetes master, to handle the workload on what spec you have defined and what it has to do for maintaining it or maintaining the state. Clear? Clear until now? Master and worker, and what are the components we need?
Yes, sir.
Okay. Now typically the next example, whatever, or the next topic that we have to take, I just wanted to show this cluster so that it will be easy. Okay. So now we'll go back to, now in the last class, yeah, we were trying to understand the HPA, right? Now, so we were understanding a couple of objects, right? We understood a deployment object, and then we understood that we have a service, and then volumes, and health checks or liveness probe, and then config map, and then secrets, namespace, quotas. So there are a lot of things that we learned. Now let us go back to the replication object. So can someone tell me quickly what is replication object, or why do we need a replication object in our Kubernetes?
for scaling up or down pod.
Mhm.
For resilience, so that all the components are available every time.
Okay, I'm using the exact word for that. That's correct. What you mentioned is resilience.
To
So
maintain desired
there was a word I used for that. What is it? I just now told you. Replication. So what is replication? Replicas. So you need to maintain always some replicas, right? So using a replication object, we made sure we will always have a replica. That could be one replica or two replicas or three replicas, right? So for that, which object did we use?
Replica set.
After that, did we use replica set
replica
directly?
set.
Replication controller.
No.
We have used
No.
No,
deployment object.
Yes. So in that way, we were using deployment object. Deployment object was creating replica set. So it's for your understanding, I told you, but we will never create replica set. That's what I told you. So what did you create? Deployment, right? So that's where now, so let's assume this is your cluster. So if you define an object as a pod, then the basic functionality is what? You will be just getting one pod or a container in a random machine based on this resource available. But if it goes down, you will not be able to get it back, or you will not be able to replicate or scale, correct? So that's where you now define it as a deployment object, so that based on the number of replicas that you give, now let's say that I have two replicas, then it will try to randomly create the pods on any worker machine, correct? Now understand this. In this example, just to tell you that I need two replicas and I have three machines. The two pods or replicas can be either created on a single machine itself, or it can create one in one machine. That is also possible, right? That is provided I have enough resource in a worker. So let's assume that in my worker 3, I have enough resource, so Kubernetes can create both the pods on the same machines, correct? So that is how your need is to create two replicas, and you don't have to worry about which machine. So that Kubernetes will take care. So that is how deployment will make sure that you will have the same replica available, but you don't have to worry on which machine. But now there are certain scenarios in which you want one replica available in each of the worker. Okay, so we will talk about it, but now understand what I'm saying is, I will not say I need two replica or three replica. What I will say is, hey, if I have three machines, in each machine I want to run one replica. Okay, then your deployment will not be useful, because now assume that you have three machines. So if you say three replicas, then the deployment again might create all the three in one machine, or it might create two in one machine and another one in another machine, and the one will be left out. So this is where we will not be able to know on where it will be creating. So instead, if we have a requirement where on every worker that you have in your cluster, you want to have one replica running, then we are going to use a new object called as daemon set. And what this will do, this will not ask you how many replicas you want. It will just go and check how many machines are there. Based on that, it will be creating replicas. Okay, so that way daemon set is also another type of replication object, but the difference is you will not give how many replicas you want. You will just say what is that replica you want, but the daemon set will check how many machines are available. Based on that, it will be creating one replica on each of the machine. And not just this, tomorrow if you add a new machine to the worker, automatically the daemon set will try to make sure to create one more replica on that new machine. Or if one machine goes down, accordingly it will try to internally manage, saying that okay, I don't need it. So that is how, using daemon set, we will be able to create a replica on each of the node. Okay, now why do you need to do that? So there are some cases where if I tell you, okay, I want to collect some log information from all the node. For that, I have to run some application through some container. Then instead of we going and doing it, I can create an object called daemon set, and that will create one container or replica on each of the machine, right? Or think of monitoring. So I want to monitor something on each worker node. Then I can again create a container or a replica which will be running on each of the machine. Okay, so remember, so daemon set means it will create one copy of your replica in every machine, so that you are not going to tell the number of replicas, and the daemon set will be seeing how many machines are available, and in each of the machine it is going to create a replica. Okay, so now for this, if you are defining the object, so you're going to say the kind as daemon set, and then the API version is apps v1, because again if you go back, deployment was also under this, right? So it's the same. And then the metadata you're going to give, which will be exactly the similar, like name and label. Okay, but the major difference over here is you will not be giving a replica. Okay, so just like how you had the deployment object details, right? The same thing is what you're going to have, but the difference is you will be specifying the kind as daemon set, and over here you will not be specifying the replicas, because the replicas are chosen based on how many machines are available. So accordingly, what we will have is the remaining things. So remaining things is you have the selector, so that it needs to know where it has to create the pod or what is the template, and that is what we have defined here. Okay, so remember, the only difference is you're not going to give the replica, and remaining all will be the same. Okay, so here, just to show you this example, I'm going to create a replica which will be available on all the worker nodes that we have. So typically we have 2 worker nodes, right? In each of the worker node, we will be getting this pod running. Okay, so to do that, now let's go to our master. Let me connect again. So now, as Ubuntu, I'll create a file. I'll just call it as daemonset.yaml. I'll put this up. Okay, before that, let me just show you kubectl get pods. There's nothing. So let's apply this. So it says it has created a object called daemon set, correct? So if you say kubectl get daemon set, you can see it has 2. That's because we have 2 machines in our cluster, right? So we have 2 machines, and based on that, it is automatically picking it up as 2. And now if you just say get pods wide, you will see this. So you can see that these 2 are the worker machines, and where is the pod running? One pod is running on one of the worker, the other pod is running on the second worker. Okay, so that's how think of using daemon set whenever you have to monitor something or you need to run a pod on every worker machine that you need. Then you will be getting it into this. Getting it? The difference? So this is also a replication object, okay? But this is going to be used mainly for monitoring or collecting some log information. For those kind of scenarios, you're going to use this, okay? However, now, when we created a daemon set, it is going to create a replica on every machine that we have in the cluster. But there will be some scenarios where, assume that you have a cluster of 10 machines. Now, you don't want to create a replica on all the 10 machines, but you want to have only on particular machines it has to create. Okay, so once again, now we can use the node selector label, if you remember. So with the combination of that, you can now tell to the Kubernetes not to create on each and every machine which is available, but instead of that, only on a selected machine you create. Okay, so if you want to do, then what we can do is, in addition to this, all you have to do is add a typical node selector. Okay, so now if you go back to your container spec, right, all we have to do was add the node selector to your container. So now I'm trying to tell, just example, node selector for this container where the label name is server and the value is group1. So again, it's just a random name I'm giving, but this is a label. So now when you apply this, whichever node has this label, it will be applied only to that. Okay, so watch this. Now I'll edit the daemon set. Okay, and okay, so now if I apply, so there's nothing, right? So let's go ahead and say kubectl apply -f daemon set. Now here it would not create. That is because you can see there is a selector that we have given for a node, and there is no node in which the label is applied, because I'm just telling you this, that's it. We haven't applied or created a label on the node. So now let us go ahead and apply a label on a node and see how it is going to take. Okay, so how do we apply a node? So if you go back, label command that we have, right? So we'll just get this. So I'll just say the node name, and then you're going to say the server and group. So first, okay, so let's take this. In fact, kubectl get nodes. So what I'll do now here, so watch this. I'll take this node, okay, and I'll apply. Now I'm applying label to only one node. So because of that, when the daemon set runs, there's only one machine on which it is available. So it will create one replica. Okay, and accordingly, if you say kubectl get pods, and you can see it's running. So that's how you can selectively choose on which machines or group of machines that the replicas should be created. Now, if I go ahead and apply this on the second machine also, 0 to 28, okay, it's applied. So again, now if you say daemon set, it's trying to bring up, okay, so desired is 2, so it automatically took it up. And based on that, if you say get pods, you should also see another one running. Okay, so this is how, when you try to have a requirement where you want to have one replica of your pod on all the machines, then you can use daemon set. but in that also you can specify which group of machines that it should create. Okay, so this object is what we call it as daemon set. Getting it?
Yes, sir.
Okay, so we'll do one thing. Just let's take a short break. Okay, I'll stop it for now.
This conference will now be recorded.
Okay, so now when we went back to persistent volumes, right? So what we saw that if you want to use a persistent volume, first you need to create a volume in AWS or a cloud, and then based on that you have to create a persistent object or a persistent volume object in Kubernetes, which is PV. And then whenever your object is going to be referred, then you will use the persistent volume claim, and with the help of that you were trying to use it. All right, now this is what we call it as static provisioning. Okay, so now when you go to production grade, it's what will happen is it will not be always that you have to create a volume first. So what we need to actually do is dynamically provision the volume. So that's where now this is what you have done earlier or what we saw earlier. Okay, so you will first create a ABS volume and then try to create a PV object by telling what is the volume ID. And then when we try to write a manifest file, we define that, okay, what is my PV claim, which will try to use this, and based on that your pod or the containers was created and the volume got mounted. But now for various scenarios, what we would actually need is to do the same thing dynamically, because I cannot keep creating objects separately and then use a claim to refer. Now the whole of that should be happening dynamic. So what do you mean by dynamic? Okay, now in this method, what we were doing earlier, you were creating the volumes first and then the persistent volume objects first, and then you went ahead and creating the claim, right? Now instead of that, now we also have a concept called your dynamic volume provisioning. Here what will happen is, instead of you defining or creating persistent volume objects, you are going to actually define a new object called storage class. Okay, so where a storage class represents to a persistent volume and a claim associated to it. So this way, in every cluster, you are going to actually have something called as a storage class, and a storage class will be associated to a cloud which knows on what is the type of volume that it has to create. Okay, so in this way, whenever you are trying to create a cluster, you need to first create a cluster, and in that you need to mention what is the storage class that you're going to have. Now for example, if we are going to use AWS for our Kubernetes cluster and for the storage, then I can say my storage class should refer to AWS. So from this way, whenever you're trying to define your manifest, you are going to just use a persistent volume claim, which can be associated to a default storage class, or during runtime, you can also specify your own storage class that has been defined or used. So this way, what will happen when you try to execute your manifest file, you will be just using a persistent volume claim which will have a storage class, or there can be a default storage class which is mentioned already, so that whenever you apply your manifest will read to the PV claim and it will check is there any storage class that you have defined here, or you can directly refer to the default storage class. Now, regardless of that, when you apply your manifest, the manifest will read a storage class, and based on the storage class type, the storage class will automatically connect to EBS, or in case if it is AWS volume, and then dynamically it will create a persistent volume object and that will get mounted. Okay, so this method of creating a volume and mounting when you need is what we call it as dynamic volume provisioning. Okay, so here you are not going to create a volume on AWS, or you're not going to create a PV in your cluster. Both of them happens dynamically using the storage class. So as a user, now we just have to think about, okay, should I be using my default storage class, or should I be defining a specific storage class that I can attach it to my PV claim? But again, the storage class definition should be done by the administrator. So our work is to just think what is the storage class that I should use, so that now even if we don't know, then everything can go to the default storage class, where if I am the administrator, I can make sure that the default storage class will be specified to a AWS volume on EBS, so that whenever you run your manifest, it will create a volume based on AWS and create a PV accordingly. Okay, so this is what we call it as dynamic provisioning. Now remember, when you go to actually in your cluster, you need to define your storage class also. Okay, so it's not always that you will be using static volume, but you will also be using dynamic. But for this, you need to first mention a storage class. That could be a default, or you can refer to your own storage, but that should also be created. Okay, so you can have more than one storage class types in your cluster. So that's where, if you look at this, now these are the providers that we have, right? Now according to it, these are the storage class types that we have. Okay, so suppose if you want to set up the AWS EBS volume to be your default class, then you need to create a class which will be referring to the object of the type GP2. Accordingly, for different class or the different providers, you will be having few things accordingly. Okay, now just remember this much, so that if someone talks about dynamic provisioning, immediately you should say that yes, for that you need to have a storage class, and the storage class should refer to a type of provider, wherein it can be set as default or it can be set separately, and through your volume claim you can specify which storage class that you want to use. Now the problem here for us to implement this, if it is AWS, right, then it's not so straightforward, because how did we create the volume? If you go back in the dynamic provisioning, I didn't do anything from the cluster, right? We went to the AWS console using your user ID or your access key, and then you created the volume, and that volume I just gave here. But that also, everything had to be available in the same region. But that way, if your Kubernetes master has to communicate to the AWS directly, then once again there are some steps that you have to follow, so which again goes back to your AWS administration. Okay, so it's not so straightforward that you can do. So from that angle, what I'll try to do is not to create a volume which will be on AWS, but I can try to create a volume which can be available locally. Okay, so that dynamically we can create a volume mapped into the same machine or the Kubernetes cluster that you're trying to use. Okay, so that we'll try to do it. So now, how do you define your storage class? So this is where we are going to have a new object called storage. Okay, so that's where, if you look at this, the next slide. Okay, now, yeah, here, if you look at this, On the left side, you have a new object called storage class, and the kind is storage class, and the API version is again specific to this, which is storage.kubernetes.io/v1. Now here you are giving a metadata, and you are trying to define a provisioner. Okay, and in the provisioner, do you see that you are trying to tell to refer to the AWS EBS, so that if any point of time you are going to use this storage class, then what will happen? You will be able to connect to AWS, and Kubernetes will be creating a EBS volume on AWS. And for that, what are the properties that you want to give is what you're giving here. Okay, and then accordingly, how are you going to use this? So either you can set this as default, or if you come to this side, we have the claim. So when you're defining claim, so if you go back to your earlier claim template, now we give the kind, the the API version, the metadata, everything is fine, and the resource, but we never used storage class. So that is what we are going to add now. So now when your manifest reads this persistent volume claim, and when it sees that there is a storage class available, then immediately it will come to the storage, and in the storage it will see, okay, what is your provisioner for your cloud provider, and based on that it will connect to that cloud provider, create a volume in the cloud, and then come back and create a PV object what you need, so that the PV will be created dynamically, and that is what will get mounted into your pod. Okay, so all those things will be dynamic. Now you can try running this, but like I said, your Kubernetes will not be able to connect to AWS. But that way, just understand that for doing dynamic volume provisioning, what you need is a storage class. Okay, which you can set it as default, or you can give it through the PVC claim. Okay, so this is one. But anyway, now let's not worry about it because it's just a point on an advanced way if someone asks. But I'll show you how we can do a dynamic volume provisioning as we move to the next step. Okay, but to understand the logic, if you want to do a dynamic provisioning, first you should have a storage class, and that storage class will tell to what provider that you want to connect for creating the volume. And to refer to the storage class, you will have a persistent volume claim which will say this is my class. And if you now define your object, like in this example there is a pod, and in the pod under the persistent volume claim, okay, so here let me just see. So here you are going to give the claim name. So when you are using this claim will refer to a storage class, and with the help of the storage class, we will be able to dynamically create a volume. Okay, so that's how. If you refer to the storage class in your PVC, then it becomes dynamic. If you don't refer, then it will search for a persistent volume object which is available in the pool, and from that it will be picking up. Okay, so that's the basic difference with storage class, without storage class. Okay, now you just keep it for understanding for now, so that the next topic, whatever I'm going to talk, requires a dynamic provisioning. Okay, so that's the reason I was just trying to use this. So what is the next topic that we have to learn, which is more important? Now, once again, when you talk about replication object, we saw deployment and we also saw daemon set, correct? But there is another type of replication object which is called as stateful set. Okay, hello, can you guys hear me?
Yes, Adam.
Yes.
Okay. So now there is another type of replication object, which is stateful set. Okay. Now, why do we need it? How to use? We will see. But before that, let's understand a few concepts. Again, see, learning Kubernetes is not just about commands. Okay. Because internally you need to know what kind of applications you are running, and questions will be based on that. Because in an interview, if someone asks you a simple question, okay, what did you run inside your object? Okay, you cannot just say deployment or whatever, but what type of application you should also be knowing. So stepping back, if you take an application, okay, you can take any application, and we know that, see, if it is running on premises or if it is running on a particular machine and you're accessing it through command line, then we call it a standalone. The same thing if you're accessing it through web, and then it is called as a web application. So that's a different type. But in the nature of how it is going to work, it can be divided into two types. One is stateful, the other one is stateless. So let's see about the stateless application. See, if you have an application, and for that application, if it needs some data that it is going to store, and if that data is going to be available outside or on a different machine and not in the same machine where your application is running, then they are called as stateless application. And typically all the applications what we have seen so far is stateless, because now if you want to deploy a stateless application using Docker, you will have an image. So that way, now if you create a container from the image, wherever you create, application will start, but the database that it needs will be available on a different machine. So that's where, if you understand this diagram, if I have an application like my Tomcat or JBoss or Nginx, it doesn't need the database to be there, correct? So wherever I want, I can just start up my container, and that will connect to a database which is available somewhere else. So such a kind of application where the database is kind of available outside your container or the machine is what we call it as stateless. Because this is where you will be able to do load balancing, and you can just stop and start. Because if my pod goes down, I'll create another pod, and that pod will again connect to my database. So that way I don't have to worry about starting and stopping my pods. So that is what we call it as stateless. Okay. Now we have another type called as stateful application. Okay, so what is stateful application? Now for this kind of application, it is not just about starting it, but whatever the data that the application is going to store, it is not going to store somewhere else. It is going to store in the same location where your application is running, like database, correct? So now think, if I create a container in which some database is running, whatever the storage that you do, like whatever the tables and rows that you create, where will it be stored? It will be again stored inside the container only. So now such a kind of application where you have the database related to it stored in the same place where it is running. So that way now, if I'm going to create a container for database, then I will have a container inside which my application like MongoDB, or I will be having my Cassandra or MySQL, Oracle, whatever that you take will be running. And inside that, the storage will also be there. So that way, such kind of applications is what we call it as stateful application. So whenever someone says stateful, you should think of database, and remaining all of the others are stateless. Now, why are we trying to understand this? Because now when you have an application of the type stateless, like how we had our JBoss or Tomcat, right, or Jenkins or Nginx, everything is stateless. So that is where, if you want to make sure that your stateless application is replicated, then deployment will be suitable. okay, or the deployment object will be suitable. But now, how does it work? Okay, so just to recapture, now if I define a deployment object, then if I tell, let's say that I need 2 replicas, then what will happen? The deployment object will create a replica set, and the replica set will create 2 pods. And for each pod, you're going to have a unique IP. And then in order to access this, you will be accessing by creating a service VIP, which will be applied on top of it. Okay, so that now you don't have to worry whether to go to this pod or this pod, because it will be doing a load balancing. So that way you will access the VIP, and VIP will be internally doing the load balance, so that if you access any one of the pod or container, it is fine, because for both of the pod you are going to have a same database which is going to be connected. So that is why we call it as stateless. And if I try to have a volume defined, then if you understand, it will be the same volume which will be shared by all the pods. So that's where how many ever replicas that I create, it is actually called as replicas, because whether I go and access this or I go and access this, I should be getting the same data. So that's where when you're trying to define an object through deployment, what we are going to get is a shared volume. Okay. Now, think of this where if I replace this container with whatever application like JBoss, which is or a Tomcat, which is a stateless, with a stateful application like DB, then what happens is at the same time, whenever I try to access, I should not be accessing both the copies, because always I should be accessing only the master copy. Okay, because now assume that my requirement is whenever I access, I want to always access only the first pod. Then what will happen? If I use the VIP, then the VIP can help me to reach this, or sometime in the load balancing, it will also reach here. So that's where whenever you have a stateful application, whatever requirement is actually that we should have one pod which is unique, and every time I access, I should be always accessing only that pod. Because when you are trying to have something like database, and when you are having multiple replicas of database, we will call the first one as master, the other one as client. So that way, now whenever we access for a stateful application, remember, we should always access one pod at a time, and I cannot use VIP for it, or I cannot use a IP for it, because if this pod goes down, a new pod will come, then I will not remember the IP. And at the same time, I cannot use the VIP, because if I use this VIP, it can send it to this pod or another pod, but I want to always access the first pod. Okay, so that's what stateful applications require. And the second thing is, for a stateful application, you cannot share the volume, because every time when I am accessing it, it should have a unique volume. Then why do we need another replica? So this replica is just going to act as a backup. So that is where for every replica, you are going to have a separate volume, which is not again possible in deployment, because in deployment, it is giving me a shared volume. Okay. And the third requirement that we have in a stateful application is, when I try to say I want 2 replicas, then in deployment object, what happens? It is going to create all the pods at one time. So if you go back and just refer or refresh and see, when I say kubectl apply, immediately it will be trying to create both the pods. But when you have a stateful application, you don't want to do that in that fashion, because first, always the master pod or the first pod should come up. Only after this comes up, the next one should be coming up. Okay, so that is what we call it as sequence or order. Same way, if I want to delete, if you have created a deployment object, I mean, I say delete, have you noted? Immediately it will be deleting both the pods. But if I have a stateful application, then when I say delete, it should be deleting in a graceful order. That means it should be stopping the replicas first and then it should come back to master. So how are you going to get this order possible? Because if you use the deployment object, it will not be working for your stateful. So that's where deployment object is more suitable only for stateless application. So now whenever you have a stateful application like database and you're trying to create a container or a pod or a replica for it, then you should be using a new object called stateful set. Okay, so that's the reason you should remember the word stateful. So stateful applications will need an object called stateful set. So how does that work? So now if you define an object called stateful set, the first thing is it is not going to use replica set, because how does deployment handle your replicas is through the replica set. Actually, if you see, replica set is the one which will be creating the pods immediately or deleting it, or if you're creating a service, it will be communicating to the replica set, which will be redirecting you by doing load balancing. So instead of that, if you create a stateful set, it will be having its own controller. So it will not create replica set. Okay. So because of that, now when you try to say, assume that I want 2 replicas, the stateful set will have its own controller, and this controller will not create all the pods at one shot. So it will first create one pod, and that pod will be named as pod 0, and this will be acting as the master pod. Okay, and then once the first pod is successfully up, then it will go ahead and create the second pod, and the second pod will have the number called pod 1. So this is how, when it is creating, it will be creating it in order, and the same way when you try to say delete, it will delete the pod 1 first and then it will come to pod 0. So that is graceful shutdown. Okay, so you can achieve that using stateful set. Then that is one point. The next point is, when you try to create a stateful set object, then a stateful object will be internally using persistent volume. Okay, and in that it will be using a dynamic volume provisioning. So that way, for each pod that you have in your stateful set, it will be creating a separate persistent volume. Unlike your deployment, it will not share. Okay, so this is another thing that we need to know. So that's where, for this point, I was talking about dynamic volume provisioning. Okay, then this is the second one. One is it creates in order, and second one, it creates a separate volume, not shared volume. And the third one is, now if I create a service and if I define an IP which is VIP, then problem is, if I access the VIP, it is going to go randomly to do load balancing. But when you have a stateful application, you don't want to do your load balancing. You always want to access the first pod or any of the pod of your interest, which is going to be called as master. So that is where what we are going to do now is, in stateful set, we will be creating a new object or a service which is called as headless service. If you remember in the beginning when I was explaining you types of service, there was a fourth part which is called as headless service. Okay, so what is headless service? So headless service means when you create a service, it will be applied to your object, and in that object it will not do a load balancing because it will not give you a VIP. Okay, now instead of the VIP, it will be giving you what we call it as a unique identifier. Okay, so there will be a unique name given to you, and whenever you refer to that name of your service which is unique, it will always go to the default master pod, which is pod 0. So that is where anytime you access that unique ID, it will always go to that particular pod. So that is how, for stateful application, you don't need the service. of the default type. Instead, we are going to create a service of the type headless, and in the headless, it will not give you a whip. Instead, it will be giving you a unique identifier, and that is what we are going to use. Okay, so that's another point. Getting it? So this way, now, if you look at the difference, when you create a deployment object, what and all it does. So typically, it is going to create all the pods or replicas in one shot, and when you delete, everything will get deleted in one shot. Whereas your stateful set will create the replicas in an order, and you will have the number for that also. And second difference, your deployment object will have same volume shared across all replicas, but your stateful set replicas will have a separate volume for each of the replica. Okay, and then your deployment object will use a service whip, and using that, it will be doing a load balancing of going to the pod. Whereas in stateful set, we are going to create a headless service which will not have a whip, but it will be giving a unique identifier which will always refer to your first pod. Okay, so these are the differences. Okay, so remember, this is how it is going to work. So to see this, just to understand, now what I'll do is I'm going to quickly create a pod. Now again, I don't want to use a database because if you guys are not comfortable what is database, how to go. So that's the reason I'm just going to take Nginx image. So Nginx, if you look, is actually a stateless application. Okay, but still, just to show you how this new object called stateful set works, I'm going to just create it. And for that, I'm going to use Nginx. Okay, now I want to give a attention over here. So what is the difference? So now this is just similar again to your deployment object, but there are a couple of changes that we have. The first one is the kind of the object, which is stateful set. And again, the same API version, which is apps v1, but the difference is over here. But under the spec, do you see there is something called as service? Okay, so far we never gave a service name in your object, right? But here we are trying to tell what is the service name that we want to have. Okay, now other than that, the replicas, the selector for labels, and then your pod template, everything is going to be the same. Okay, now I'm using Nginx image. Okay, now further we have a volume mount, and in this volume mount, I'm trying to say that whatever the volume I'm going to get, that should be mounted inside my container under user share Nginx HTML. Okay, and now the actual point comes is, okay, from where I am going to take. So that's where we are going to use a new topic called as volume claim template. And what this will do, this will be actually accessing your default storage class, and it will be dynamically creating a volume, and it will be mounting, because it's not a host path. Remember, I have not given it as host path. So dynamically it is going to create a folder, but again, that will be more into your master only. Okay, so that's how we are trying to create a dynamic volume using the claim template. And for that, I'm telling that I need 1 GB of storage, which will have read write once. Okay, so that's the difference. If you remember over there, we used to have read write only or read write once. So that's where the another type what we have is read write many. So depending on what type of application that you're going to use, you have to give the access mode as either read only or read write once or read write many. Okay, now typically if you have database, then here you are going to say as read write many. If not, it is going to give a control on read write once only. Okay, so that's what we have the object defined. And then on the other side, we are creating the service. So in the service, if you look, I'm giving the same default template and I'm giving port 80 because which is what is going to map, but the cluster IP is none. So this is what the keyword that you have to use, because if you don't tell the type, by default it will become cluster IP. So that is where you are going to explicitly add this word called as cluster IP is none, by which Kubernetes will know you are trying to create a headless service. Okay, so these are the changes that you have. Okay, so now let's try to apply this and see how it behaves. Now for this, let me just take your Minikube. That is because if you are going to your actual cluster, then you need to define a storage class. So that's where again you need to know the administration, AWS, all those things will be there. But if not, if you go to your Minikube, right? Now Minikube comes with a default storage so that you can use for your practicing. So I'm just trying to connect to Minikube. So you can see now in the Minikube, it comes with a default storage class, which refers to the same machine. So that's where now it's easy for you to do the dynamic volume provisioning in this. But if you go and run the same thing on your cluster, you have to set up everything. So that's one of the reason why Minikube was meant for helping you in the development activity very faster. Okay, so assuming that we have already a storage class created and that is also default. Now, if I go ahead and apply this, okay, so what I'll do now, I'm going to create an object, and this object will be of the type stateful set with 2 replicas. Okay, and then this will be having a volume wherein we will see now it will be creating 2 volumes dynamically. Okay, so before that, I'll just show you kubectl get pods. There's nothing. kubectl get pv. You can see there is no persistent volume or there is no persistent volume claim. So that thing is available, right? But watch what happens. So here we'll say STS. So STS is the short form for stateful set. Okay. Now, same way I'll edit a file called STS SVC. That's for my service. So here, let's add our service definition. Okay. So first, let me go ahead and say kubectl apply -f the service. Okay. So here, if you say get SVC, you can see now we have created a new service which is headless. That is where there is no IP that is given to it, which is the VIP. Okay, so I'll not be able to use it outside. So within the cluster only I'll be able to use, and we are going to use a unique ID. Okay, kubectl describe svc nginx. Okay, and now that unique identifier is nothing but the name of it plus the pod name. So I'll tell you as we start the containers. Okay, so now you can see we have created a service which doesn't have a VIP, which is headless. Now, before I say kubectl apply and create our object, let me connect to this machine on a different command prompt so that we will see that it is going to create the pods in a graceful order, right? Because that's what I told you, it is going to do one by one, correct? So I'm just connecting to the same Minikube. Okay, so what we will do now is okay, so I have the same, I've just taken it into 2 screens. So watch this. Now I'll go ahead and just try to apply the file that we have. Okay, so this is what I'm going to do. So watch this. So I'll apply here, and before that, here let's say watch kubelet get all. Okay, so right now what we have is only one service, nothing else. But see what happens. So watch it very carefully. So it's trying to create an object called stateful set in that 2 replicas, but you can see now first the 0 pod comes up, okay, and only when it is successful the next one started coming up. Okay, I'm not sure if you watched it, but let me delete it and again I'll show you. kubectl delete. So watch this. Okay, now internally you deleted the whole, but you try to scale down, you will see it. Okay, now watch this again. I'll say apply. Okay, so first pod will come and only when it is successful it will go to the next one. Okay, now this is what stateful set will do, but the same thing if you have defined it as a default deployment type, then immediately both would have been coming up. Now I'll try to scale and show you what is going to happen. Okay, so here you see that there is a new object called stateful set has been created. Now here we will also see that you should be seeing a persistent volume claim and persistent volume object, both of them being created dynamically. Okay, so how do we check that? So now I'll just close this for a minute, and now if I say kubectl get pvc, you can see there are 2 persistent volume claims available, and accordingly there are 2 volumes available. Okay, so this is how, using the default storage class that we had, it mounted a folder on the same Minikube and it has created 2. So that is the next difference, wherein in stateful set for each replica you are going to have a separate volume. Okay, so that's the next difference. Now to show you further, okay, let me go ahead and scale it. Okay, so now, okay, before I go to that, now let us see how our service behaves. Okay, now if you want to access this pod or replica, this is where you are going to use a identifier. So what is that identifier? So you're going to tell your pod name dot service name. Okay, or you can directly say service name. So that way what will happen, it will always go to the first pod only. Okay, so watch this, what I'm trying to do. Now I'm going inside. See, now ideally we have 2 pods, and look at the naming convention, which is the first one is the master and then the next one. So if I run this, what is happening here, you can see I'm trying to go inside the first pod and I'm trying to say curl nginx. So what is nginx here? Nginx is the name of the service. So internally, it is going to again refer to your first pod only. Okay. The same thing, I can also go back and I can say the same to my second pod, and again, it is going to refer to your first pod. Now you might ask question that how do you say that? Because both of them are Nginx, and when I say service, which one it is reaching? So you don't know, right? Now that's where, see what I'll do. I'll go to the first pod, okay, and I'll try to run this command where what I'm trying to do, I'm going inside the first pod and the default HTML page, right? So in that, I'm just adding a word called test so that when you access the first pod or the Nginx service, it will always reach to your first pod, and that should be giving this test, not your default HTML. What I'm trying to say that is, see, if I run this, it is going to my master pod, and this is the default HTML page. Now I'm replacing this HTML page with just a test command or a echo test screen. So that's where, now look, when I access the same, okay, so this is typically accessing it inside, but instead of this, now if I go back, okay, and try to access through my service, you will see that it's trying to redirect it. Okay, so you will be always accessing. So this is where you're not going to use your service name, because the service name refers to the pod, but now what you're going to refer is the pod name and the service name. Okay, so that way, now watch this. Now if I refer this, it is going to refer to my second pod where I have not changed, but the same, if I just say from whichever pod, if I say pod 0, it'll always refer to your test. Okay, now I can do this from your web 1 also, it'll work. Okay, now, this is how we are actually going to refer this. Okay, so you're going to refer to your service name. Now this is not available outside, as you see, so it will always refer, okay, to communication. So that's where all these things are only needed to communicate between your pods in the same cluster. Okay, so that's how every time you access, you are going to use a unique identifier, which is nothing but the name of your pod and the service name, so that it will always be going to a particular pod. So you choose which one will be acting as your master, and you will always be able to access. Whereas in the previous deployment type, we saw that every time when we have to access, we were dependent on the pod's IP because the name will be changing. But here, no matter how many times you are going to recreate, the pod will have the same name. And that is how you will be able to clearly access a particular pod using the unique identifier, which is the pod name dot service name. Okay, so that's again what we mean by headless service. So you're not going to access through your VIP, but using your service name. Okay, so this is the second one. But now let me show you the replica, so that now watch carefully. We have two replicas, right? I will change it to replica 5, but what will happen is it's going to scale it in a order, not everything together. Okay, so it's the same command kubectl scale, but the object is different. Okay, which is sts is stateful set, and the name of our object is web app. So watch this now. I have this. So here once again I'll say watch kubectl get all. Okay, so we have stateful set with 2 replicas and 2 pods are there, right? Now here, let me scale it. Okay, just watch it now. it should create one. So you can see first it created this container, and when it is success, then it is going to third, and then when it runs fine, it goes to the fourth. Okay, you saw that quickly it did, right? Same way, I can scale down. Now if I scale down, watch that the same way it is going to do a graceful shutdown. So it will do one by one, then this, then this, and then this, and then it will come back. So that is how for everything you are going to have replication. And not just that, for every replica that you created, if you go back, you should see there is going to be a new persistent volume available, and correspondingly persistent volume claim also available. Okay, so that's the difference between stateful set and your deployment object. So you're going to have a persistent volume for every replica that you're creating, and you will be having a headless service. To access, you're going to give the unique identifier, which is a combination of your pod name dot your service name, so that you will always refer to a particular pod. And whenever the pods get scaled up or scaled down, it's always going to do in a order. Okay, so that's the basic difference between a stateful set and a deployment. And now you need to think what type of object you're creating. So based on that, you have to say whether it's going to be a stateful application or a stateless application. Getting it? Let me stop here. Getting the difference? Now, what are the different